My name is Shauna Gujarati and I am going to introduce and demonstrate our project for CMPE 239 Movie Recommendation System. What's unique about this project is that we have solved the cold start problem. With me are Nakul, Ankit, Shrihar and Tejas. So what are we doing in this project? We are going to do content based collaborative filtering. For this we are using Pearson Correlation algorithm. Content based collaborative filtering relies on the past views of the user, what user has seen in the past and what others in the proximity of this user have seen in the past. Based on that, movies are recommended to the user. But what happens when the user hasn't seen or hasn't rated any movies, or what happens when the user has rated only one or two movies? How do you recommend things to him? For that, we are going to use genre correlation algorithm and Bayesian weighted ranking algorithm. I'll talk in detail about this later on. The high level architecture is that we are taking the raw CSV data, which can be seen over here, and we are saving it in Cassandra. Cassandra is a NoSQL database. What's good about Cassandra is it lets us store data in a sorted format, so that from a model view controller architecture, the controller can just fetch the data from Cassandra in a sorted order and show it on the UI. The three algorithms we are using are Pearson correlation, Bayesian average and genre correlation. So let's start with Pearson correlation. I'll show you how I have implemented it and talk about it to explain it. Then I'll demonstrate the algorithm. So in Pearson correlation, we take the data, all the data set and make a model out of it. Pearson correlation is applied to this model and we get the similarity coefficient. Then for everyone within the threshold is found out in the neighborhood of the user. So what this means is that we find every other user who is in proximity of our user, and we see what movies those people have seen, and based on the movie watching patterns of those users, we recommend movies to our user. I'll demonstrate this. So say user 1 who has seen a bunch of movies. In the database I'll show you user 1. User 1 has seen a bunch of movies, so we can safely use Pearson correlation to give him recommendations. So these are the movies that were recommended to the user, and this is a real-time algorithm. So every time I click on home, it's going to calculate the similarity on the go. So what Pearson correlation returns is that the recommendation value, how much is the movie recommended to the user. For example, the Little Shops of Horror is highly recommended because the recommendation value is 5. It's the maximum. This is how in general Pearson correlation works, and this has been implemented numerous times in the past. Now I'll start with the unique part of our project. Weighted ranking using Bayesian average. So when the user has seen nothing, there are 0 movies that the user has seen, we have a cold start. How do we solve this problem? So Bayesian rating is a method of calculating the top movies. Now how do you calculate top movies? Do you give preference to the ratings? The top rated movie will be considered the best movie, or do you give preference to the views? The top viewed or the most popular movie will be considered the top movie. How do you do this? How do you weigh these two properties? For that, Bayesian rating comes in. What it does is it takes the average rating of the movie given by all the users. Then it also considers the number of votes and the minimum number of votes required to be listed or to be taken into consideration. For us, it's 5. It also takes into consideration the mean vote of all the movies to compare it with, and give a proper result. So, this is the formula for Bayesian rating that we have used. I can explain it better from the code. So, what Bayesian rating does is it uses this formula where we calculate the count and the average rating and so on. This formula implementation can be seen in this SQL query. So, I'll show you how it works. In our database, we have made user 2 such that user 2 hasn't seen any movies, and now I'm logging in. And if you see the top movies, these are the movies calculated as top based on the Bayesian average. So, Shawshank Redemption is the highest rated movie with 4.4 value. That is the Bayesian average for Shawshank Redemption was 4.4, and that's what the recommendation value is. So, based on this, the user is going to get the top 10 movies in the database, and it is highly likely the user will select at least one. Once the user has selected the movie, we can then take into consider our other algorithm, genre correlation. And when the movie has seen a lot of movies, then we can take into consideration the Pearson correlation algorithm, and so on. That is how we improve our accuracy of recommendation. But to start with the cold start, this is a very good solution. So, I'll move on to a genre correlation algorithm. Now, in our database, we have a special user 999 who has seen the movie 667. It's an action movie and he has rated it 5. That means he immensely liked it. Now, based on this, we have to find a genre which is similar to the action genre. Genre correlation algorithm was based on a paper published in the Springer's Science Business Media conference in New York. The paper was published on 10th April 2016. That means it's fairly recent, and we are one of the first people who have actually implemented it. So, what exactly is genre correlation? Genre correlation takes into consideration two things: genre probability and genre weight. Genre probability is nothing but the support. If you give two genres, genre A and B, and you want to find out the similarity between these two, the support is calculated by all the movies in the database that belong to both A and B upon only those movies which belong to A. Genre weight calculates the penalty. If a movie contains a genre, but along with that genre, the movie also belongs to 5 other genres, then the importance of that one genre becomes less. So, genre weight is calculated based on that penalty. Whenever we and eventually we have to add both these values to get the actual relation between the two genres. So, now for a user 999, he has seen the action genre, and let's see which is the closest genre there is to action. Western. So, in our database, what the genre correlation calculated is that action genre is the closest genre to action is Western, and this was not based on users input. This was based on the input of experts who have given each movie the classification of genres. And because the user watched one action movie, he can watch we can recommend a bunch of other action movies to that user, which are also from a different genre. In this way, we can expand the user's preferences, and we can get more recommendations from him, so that we can move on to Pearson correlation as soon as possible. The implementation of Bayesian average based on this formula can be seen over here. genre correlation. This is same as what the formula tells us. It is basically genre probability plus genre weight, and genre probability is calculated in their corresponding functions, genre probability and genre weight. This code can be verified from the code that I am submitting. So, this is how genre correlation works. So, essentially we are giving a solution to the cold start problem by introducing these two algorithms. Bayesian average gives you the top 10 movies, and genre correlation gives you the genre which is closest to the movie that you have already watched. Based on that genre, we then recommend the top 10 movies of that genre. So, the data sets that we have used are taken from MovieBean, and the requirements are what we use in the database: Apache Spark, Mahout, Cassandra, and Eclipse IntelliJ environments. So, we have a model view controller pattern. Um, the testing was done with consistency tests, like multiple runs on the same data to verify results are consistent, dividing the data into test and training data, and seeing if the results match. So, that is all for this brief demonstration. I hope you liked it. Thank you.